Hello friends, today we'll be looking at a concept in quantitative ability which is the work time concept. So let me tell you how we are going to go through this. So I've chosen the 4 questions from both the slots of last year's CAT paper, and we're going to go through the conventional method of solving them as well as an alternative method to solve them so that we can reduce our calculation errors. So let's get started. So this is your first question. Please take a pause and reflect at the question, solve it if you can before we go ahead with the solution. So this is a normal method which involves fractions, tedious calculations and all. So if you're a person like me who would be absolutely sure that you'd make at least one calculation mistake in this whole process, so I'd say rather skip this process. Let us see how we can do this in a much simpler manner without these tedious calculations. So before we go ahead with that, the first thing that we should do is we need to put down all the information that has been given in the question. So, and we know that the total days taken in the first case is 12 and the total days taken in the second case is 9. So for this method, first we need to make an assumption. The first step that we have to do is we'll have to take the LCM of 12 and 9. The LCM of 12 and 9 is 36. So we'll have to assume that the total work done comprises of 36 different units. And so with this calculation, we know that the first case takes 12 days and the second case takes 9 days to complete 36 units of work. So per day in the first case, 3 units of work gets done. And in the second day, 4 units of work gets done. This is nothing but 36 divided by 12 and 36 divided by 9. So once we have this information, we go ahead and subtract equations 2 and equation 1. So we equated, we know that when we do the addition, subtraction part of it, we get b equals to a plus 2 by 4. So what do we do with this b? We take this and we substitute it in the first equation. Simple linear equations, right? We substitute it in the first equation and solve for a. When we solve for a, we get the answer that a equals to 2. So what does that mean? That means that a alone working can complete 2 units of the work in a day. So the total units of work is 36 and a alone can complete 2 units of work a day. So that means a can complete the entire work in 18 days. Which is our answer. And we have arrived at it without all the reciprocals and the tedious calculations, with simply forming linear equations and solving them. Now we move ahead to the next question. Once again, please take a pause, reflect on the question, try solving it, and then let's see what the answer is. So once again, this is our normal method, which, as you can see from the length, is very tedious. It involves multiple fractions, calculating with the fractions and all this stuff. Let's see how we can make it easier. If you want, you can pause the video and have a look at the normal solution. Let's move ahead to the alternative solution. So once again, we'll have to first put down the data which is provided. We know that Anil can complete the work in 20 days and Sunil can complete the work in 40 days. And the LCM of 20 and 40 is 40. So with this, we can calculate that per day, Anil can do 2 units of work and Sunil can do 1 unit of work. But there's a peculiar bit of information that is given in the question. Bimal does 10% of the work. That is, Bimal does 4 units. 10% of 40 units is 4 units. So let's park that information aside. We'll use it as and when we require further in the problem. So we know that the first 3 days, Anil works all alone. And per day, he can complete 2 units of work, which means that in the first 3 days, Anil completes 6 units of work. And so now Anil has completed 6 units of work in the first 3 days. Bimal in total has done 4 units of work. So the work that has been completed comes to 10 units. And we know that the total work is 40 units, which means that the pending work is 30 units. Now let's get back to a table. We know that from the fourth day onwards, Anil and Sunil start working together. And from our table, we can see that when Anil and Sunil work together, they can complete 3 units of work per day. So the total work pending is 30 and the work they can do per day is 3. A simple calculation will say that we need another 10 days to complete the remaining work. But this is where we have to be very careful. People will end here and say that the total number of days is 10. But poor Anil, he worked for the first 3 days all alone, right? So we'll have to factor that in too. And so the total number of days is 3, which Anil worked all alone in the first 3 days, and 10, which all of them worked together, which adds up to 13, which is our answer. Moving ahead, let's see another type of problem in work and time. You can pause this video and have a look at the question. So one concept that we have to be thorough is the fact that when you say that A can finish a job in half the time as B, it translates that A is more efficient and it's inversely proportional. So A is twice as efficient as B. So let's see how we apply that here. And this is a t-type question, so there's no options here. So let's assume that A is the work efficiency of a man and B is the work efficiency of a machine. With a given information, we can write it in the form of an equation. We can say that 3 men and 8 machines work twice as efficiently as 8 men and 3 machines. When we solve for A and B, we get a equation which says 13A equals to 2B. So what does this mean? This means that the working efficiency of 2 machines is the same as that of 13 men. Or in other words, the time taken by 2 machines to complete a particular job will be the same as the time taken by 13 men to complete the same job. Now let's see the question. It says 2 machines can finish the job in 13 days. So if we apply this to this equation, we know that 13 men can complete the same job in 13 days, which is exactly what they've asked. How many men can finish the job in 13 days? The answer is 13. So let's move ahead to the next question. So this is a very simple question. We'll just have to form a simple equation, solve it and get our answer. That's it. So let's start by making the assumptions. So let A be the number of hours of regular work and B be the number of hours of overtime work. We have been provided with the rates, respective rates, and we have been provided with an information that the income from overtime hours is 15% of the income from regular hours. Let's put it in the form of an equation. We know that both the time together clocks to 172 hours, the regular and overtime hours. And we also know that overtime income is 15% of regular income. So what is overtime income? Per hour rate into the number of rates. So 114 into B equals to 15% of 57 into A. Simply solving this equation, we will get that B is equal to 0.075A, and when we substitute it in this equation and solve for B, we get B as 12 and A as 160. Let's go to the question. It asks for how many hours did he work overtime. So our overtime hours is B, and the answer is 12 hours. So I hope that you got an idea of how the work time problems can be solved using an alternate method without using reciprocals and without doing all those tedious calculations. Stay focused. All the best for your exam preparations.